All right, we're going to start with example 1 today. We're going to do example 1, 4, 6, 7, and 10, and then you do the rest with the answers posted. All right, example 1, find x. All right, so looking at this picture, let's see what we see. I see two chords. This chord, get it? And then this chord. Ooh, I also see something cool. This chord is equal to this chord. I get it, this chord. I'm going to stop saying that joke. So we have two chords that are equal to each other. And if we go back to our 1A condition, if two chords are congruent, then their corresponding arcs are also congruent, right? So since these two chords are congruent, their arcs made from the chords, so let's go this one, is equal to this one, two different colors. So I'm going to kind of be a little bit slower on this. So let's say chord ST is equal to chord SR. Then, oh, can't spell then. Arc at RS is equal to arc ST. Right, take a second to process that. That's pretty much the whole lesson, right? If one chord is equal to another chord, then their two arcs are equal to each other. So the first arc SR is 115 equal to 7x plus 24. Gosh, I had to do some math. Pull up my calculator. I don't know why I had to narrate this. 115 minus 24, that's 91, is equal to 7x. X is equal to 13. And that's my answer. Right? The math is easy. But it's how do you set up? And this setup only came from this top part. This and then this gave us this. All right, go ahead and take a second to process that. Try 2, don't skip and copy. Try 2, then check your answer, and then come back. Even try 3, then come back and let's do 4. All right, for number 4, I have MP is equal to 5x minus 34. PN is equal to 2x minus 4. Find MP. Interesting. All right, so looks super confusing. You look at the picture and you're just like, what? So you just need to go one at a time, right? So let's go one at a time. So I'm going to look at this picture and I see this arc. Let's highlight this arc. And let's go this arc, different colors, so it doesn't look that confusing. These two are congruent. Oh, interesting. That's what we start off with, right? We start off with two arcs that are congruent, and these arcs are made by chords. So if we go back to our first foundational knowledge, look here. If two arcs are congruent, two corresponding arcs are congruent, then their two chords are congruent. Right, so now we're going backwards. Now we're going from arc first to congruent chords. So because these arcs are congruent, this chord, JM, is also equal to this chord, KL. So I'll mark it with a 2. Okay. But I still don't have enough, right? Because it's giving me MP and PN. So we actually need to go one more layer on this onion. So that means that if the two chords are congruent, then they are equidistant from the center. So these two chords are the same distance from the center. Because they are congruent, then they're equidistant from the center. So chords are equal. That means that this distance is equal to this distance. Let's go. 1, 2, 3. 1, 2, 3. 1, 2, 3. That means your setup is going to be. Actually, let's take this step back. Let's go from the top here. So we started off with arc JK is equal to arc KL. That's 1. 2 is we're going to go into, because the arcs are equal, the chords are equal. So chord JK is equal to chord KL. Okay. That still wasn't enough. So, but because the chords are equal, then they're equidistant. Equidistant from center. And that's going to be 1B. That means that MP is equal to PN. Now we can set up your equation. Now we can write 5x minus 34 is equal to 2x minus 4. Then you can solve 3x is equal to 31. Oh my gosh, is that right? No, I'm watching that math right. 3x is equal to 30, cheese it. X is equal to 10. 10 is good, but it does want MP, so I'm going to plug it back into MP. MP is equal to 5 times 10 minus 34. And MP is going to be equal to 50 minus 34, which is 16. Woo, that's a lot of work. All right, and we're going to go into one last problem. I know it's getting long. Stay with me. Don't fall asleep. Not yet. We're going to go and find arc MP. All right, here we go. All right, so for this one, we're going to have to find how much this is, right? So the question is asking how much is MP. I'm going to erase this so we have space. Let me get overstimulated. All right, so the question wants how much is arc MP? Question mark. Right? We do have this and this. So prior to setting them equal to each other, we are going to know why they're equal to each other, right? So look at the picture and identify this with me. This and this are equidistant. Now we're kind of working backwards. So the chords, these two chords, are equidistant from its center. Right, so chord MP, chords MP, MN and NP are equal distant from center. Because they're equidistant from the center, that means chords are equal, which means arcs, are equal. That's a bad 3. Corresponding arcs are equal. So that means this arc right here is equal to this arc. That means you can set this equal to this. So 9x minus 43 is equal to 5x plus 33. That means arc MN was equal to arc NP. And you can go ahead and solve for x. So 4x is equal to 76, x is equal to 19. But 19 is not the answer. It doesn't want x, it wants MP. So we're going to plug this 19, stay with me here. We're going to plug this 19 into the MN. MN is equal to 9, parentheses 19 minus 43. That's going to give us 128. So going back to our picture, going to clean this up. So this right here was 128 degrees. But we know that this arc is the same thing. So to find this missing arc, you go 360 minus 128 minus 128 is equal to 104. Whew, what a problem. All right, make sure you finish up to 6 at this point, and let's finish up the next video. We're almost there.